Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
But it's like if you have a lot of hoses and you are irrigating the first hose, the gray water is percolating inside the first one and is starting to be polluted. Then is collected at the bottom and is entering in a second hose. And then in this way, with different steps, you are treating the gray water, and at the very, very final end, you will have essentially clean water.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast and the Surviving Hard Times Podcast. I have Anacleto Rizzo. He's a hydraulic civil engineer, and we're going to talk about his work in sustainable water projects. So, Anacleto, thank you for coming.
Thank you, Richard, for inviting me.
Yeah, tell me a bit about your background and how you ended up working in the environmental field that you're in.
Yes, so essentially my background is a master degree in engineering, in civil and hydraulic engineering. Then I had Ph.D. in environmental engineering, in which I started instead to study a little bit more natural processes in environment. And so after this period, I had some collaboration with the university in Europe. And I met now my colleague, that is Fabio Masi, that is quite known in our field, and received this offer to come to work in Florence for Iridra. That is, maybe we will talk about later. And so essentially in the last 8 years, I worked here in Iridra as designer of nature-based solutions, essentially.
So what kind of projects are you working on right now specifically?
Essentially in Iridra, we work on NBS, so a nature-based solution for sustainable water management. And that is quite broad approach. Usually we work about water pollution control, but also urban drainage or climate change adaptation. So essentially this is what we are working, and we work both in design, so engineering, detailed design and construction supervision. But I've been also invited here because we are also partner of several research and development projects financed by EU, the Horizon Europe project, the Horizon 2020 project. And in one of these, we have been involved as partner. And so essentially we do both detailed design. And personally, I'm involved both in detailed design and also in R&D, so research and development.
All right. So what are one of your projects that specifically you're interested in that you want to talk about?
Yeah, so maybe we can go a little bit just to clarify a little bit better what we intend as nature-based solution, no? Because it's quite broad definition, similar to green blue infrastructure, but maybe talking about a little bit more on NICE project, it will be more clear. For instance, in the NICE project, we are studying together also with university the use of green walls, of living walls especially. That is a well-known technology for green buildings. So greening a wall in a building is quite well known. But the additional step that we are trying to propose and to do in NICE is to use this wall also for treating and reusing the water, especially what is called the grey water. So all the water that are coming outside our house, except the one from toilet. So wash basin, showers, kitchen, that are a little bit less polluted. And the idea is to treat this gray water on the wall and to collect this water at the end of the wall and to reuse it for not potable reuses. For instance, in NICE, we are studying to reuse for external irrigation, maybe for increasing the green in a city, also for heat island effect. But it can, after a disinfection, they can also be used inside the building for not potable reuse, for instance, toilet flushing. So we have a lot of water that we are using that we don't drink. And the idea is that it's not so reasonable to use this water, potable water, for not potable use.
So what's involved in cleaning gray water? What are some of the materials used or methods?
Yeah, so essentially the idea, especially in the green walls, that it's quite innovative. The use of green wall for treating gray water is started only in 2016. Our company, together other research institutes, started to study it. And so in this case, we prefer to treat only light gray water. It means wash basin. And this means, for instance, that if you can imagine your wash basin in your bathroom, the pipe outside your wash basin is not entering in a single pipe outside the building that is collecting everything, is collecting also what is coming outside from the toilet, but is separated. So essentially you try to have two separated pipe outside your building. Essentially you are trying to use as what we do, for instance, for wastes, the different collection of waste to facilitate the reuse. The same idea is for the water, in circular cities, is to try to separate since the beginning. So you have to imagine that you have two pipes that is coming outside your building. It go down at a certain moment. They are entering in a sort of pre-treatment to remove, for instance, hair or oil, greases or something like that. And then you pump it back to the wall that is finishing to treat the other pollutant, like, for instance, surfactants or other kind of pollutant that we can have when we wash our hands, for instance. But essentially, if you can imagine how much dirt it could be a water that is coming from a wash basin, just washing your hand, you can imagine that it's quite easy to be treated. And so this water is percolating inside the wall, usually at least three different rows. And at the end of the wall is collected in a separated tank. And from this tank, you are again deciding where to use it after disinfection, because you could have some health issues. And so essentially you remove all the main pollutant in the NBS, in the green wall, and you disinfect the water, and then it's able to be reused, not for drinking, but for many other reuses.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Well, what do you mean it's percolating in the wall? So all the treatment occurs like inside the wall, hidden from view, but still in the house?
Yes, exactly. So there are some experience also of MBS indoor, but here we are talking about outdoor. So you have to imagine a wall, the external wall of your building that is full of green. If you look green walls on Google, you can find several examples. But it's like if you have a lot of bosses, I hope to have pronounced it well, and you are irrigating the first vase, the gray water is percolating inside the first one and is starting to be polluted. Then is collected at the bottom and is entering in a second vase. And then in this way, with different steps, you are treating the gray water, and at the very, very final end, you will have essentially clean water. Pot
Okay, I
is
see.
better
I see.
than
I
rose.
see.
Yeah.
I see. So what about, why is, I know maybe it's disgusting, but why is toilet water so much harder to clean? Why is it called, I guess, black water instead of gray water?
This is a nice question, because actually when, if we started to talk wastewater, there is a mean, no? Essentially the mean is that we have the feces and urine that is also full of pathogens. And so the main aim of collecting the wastewater and to bring away as fast as possible from our cities was for health issues, because in the industrial development, if I remember well, in the UK, they observed that the very first quartier served by sewer network, they were the one less affected by, for instance, some health issues like something like cholera or something like that. No, so we started to don't want to have nothing to do with wastewater for health issues, but we forget that apart the health issues, the nature is not for nature. Nothing is a waste. Indeed, in our feces and our urine, there are the majority of carbon and fertilizer that in this moment are collected all together, brought to a wastewater treatment plant and treated to be discharged according to the environment, no? But on the other side, from the point of view of the circular cities, we should start to talk about resource water rather than wastewater. Because if we know how to deal with it, so not affecting health issues with citizens, so they have to manage properly. But these, in our feces and in our urine, there are the majority, essentially more or less the same amount of fertilizer that we could need to grow food for us. So essentially, if we would be able to close the loops of the other part of not the gray water, the black water, we would be able to have also some visions like urban farms, other kind of MBS, no? The 0 meter production of food or something like that.
So I can see the benefit, even if you separate the gray water from the wastewater of a house and the wastewater goes on as normal, but the gray water is kept and recycled. How much of a reduction in the total, wastewater output will a house have by doing this?
Yes. Now we were talking about even more to reuse also the black water. But if we would be able to retrofit our buildings, separating gray water from black water, roughly gray water is something between 50 to 70% of our water uses is really a lot. So even with light gray water, so avoiding the kitchen that are a little bit more difficult to be treated. They can be treated, for instance, in wetland on ground-based NBS. On a wall, it could be a little bit more difficult. But even if we consider only gray water, light gray water from wash basin, we are around 30% of our water consumption per day. And so treating and recovery 30%, 50%, 70% of our water consumption per day has many benefits, because you are reusing this water, and so you are reducing the water consumption per day per person, and so less potable water to be used, less potabilization, less water to be pumped from centralized potabilization plant to our houses, because we are used to open our tap water and it seems magical, no? But no one is really aware from which distance we are having our water in our houses. So it's crazy.
So are we saving 30% of the output, or are we saving 70% of the output? I wasn't clear what you said.
It depends which kind of gray water you are collecting. If you collect all the gray water, wash basin, showers, laundry, kitchen, you can reach up to 70%. If you go back instead only, for instance, shower and wash basin, you go back around 30%. It depends which kind of gray water you are separating from your houses.
Okay, but even if you didn't go crazy and get every drop, you could probably do at least 50% reduction without a problem, right?
Yeah. And if you couple also with, for instance, water saving devices, it's quite easy to reach at least 30-50% of reduction in water use. Then, of course, it's water that if you can recover from 30 to 50% of the gray water. Then if you decide to reuse back in your houses, for instance, for toilet flushing, you are saving a certain amount of water. But in general, you are a waste, 30%, 50% of what we are considering as a waste. So wastewater can be recovered for the city in general. And also the other good point is that you are not discharging to the sewer. So this means that this wastewater is not going to be produced and is not going to wastewater treatment plant, and it is not going to be spending energy for treating, for instance.
I can see it would be significant savings by doing this. That's really good. Now, for the treatment devices themselves, what do they look like? What are some of the things that are used to treat gray water?
Essentially, we started from the nicest one, so green wall are quite nice also to treat gray water. But actually, we have several options. So the treatment and reuse of gray water has been known since 20 years, more or less. And as almost any solution, you can go for gray solution or for green solution. When I talk about gray solution in this case, I mean that you have to imagine to have a sort of additional service in your house, like you have oven, you have the laundry, and you can have something very similar in space that is also treating or reusing the gray water. In this case, you are using membrane or SBR, so technological solutions that are able to minimize the size of the treatment stage you can put, for instance, in your house. And on the other side, you are spending energy for the treatment. While the other option, the green one, is to use the so-called nature-based solution, NBS. NBS, you need a little more space for doing the same treatment process, but you are not spending energy for treating the water. So this is true for gray water, but also for black water. It's the same concept. So if you have enough space, you can get rid from using energy of conventional technological solution, and you can use nature to do this. Nature needs space, so the space you can find, for instance, on ground, and in this case we can talk about constructed wetland, treatment wetland for treating and reusing gray water. In this case you need space on the ground, so maybe you can integrate this solution in your garden or in a parking area of different kind of houses. But this is not so easy because usually in very densely populated area, the space is quite limited. And this is why we go back to nice. So the idea that we need surface to treat by nature. And this surface can be found on the building and can be green building solutions. So it could be green walls, but also green roof, for instance. In this case, of course, you have some pumping because you have to collect and pump back the water, but you are not having the direct consumption for treating the water. It really depends on the context. It really tailor-made. This doesn't mean that you have a single solution that it's always the best one. It really depends on the context.
And then when you reuse gray water, what are some of the best ways to reuse it? Like fertilize crops? What are the best ways, again, to reuse it?
You can have different kind of reuse, essentially, and they can be divided in indoor or outdoor. When we talk about indoor, essentially it means recharging for toilet flushing, no? The toilet flushing tank. That it's quite huge water consumption. If you think that now they are starting to be optimized, but old-fashioned toilet flush use something between 10 liter anytime that you are flushing your toilet. So it's a lot of water, potable water that you could have drink and you are using just for flushing your toilet. That is crazy. Or the other option is to reuse outdoor. And in outdoor reuse, you can reuse for irrigation. And this is very well connected in circular cities and climate change adaptation, related to the fact that we are aiming for greening our cities again, but we don't have the water for green the cities as we are expecting. So maybe greywater, it could be one of the options to increase the green of our cities. Or other possible reuse are, for instance, cleaning of outdoor floor. It's a possibilities. Essentially this one, so irrigation and cleaning devices. If it could be used also for recovering the fire control service, for instance, any kind of reuse that is not requiring potable water. Sorry, Richard.
Well, it's okay, but even if you got a small town to do this for all the houses, you'd save a ton of water. Again, even if you get to like 30% or even 50%, I mean, that's a lot. That would really reduce the amount of water needed big time.
Yes.
Are there any pilot programs in certain towns or cities where they're trying to do this for every property?
No, this is a discussion. Sometimes it's not so. What is happening is that sometimes we have some experience in Italy, for instance, in which some city in the south are starting to ask any times that you are building a new house to have a system separating the greywater and having some treatment stage for reuse. This is starting to be asked, especially in the droughts area. And this is a level of a policy approach, a law approach, based on single municipality. So this is starting to be, at least I've seen some of these regulation.
Yeah, no, I can see even if you don't do anything else, but you just set up the houses so that the water is separated, then later on you can do more. It's already set up to do that. I don't know if anyone's tried this, but on a house that has this, how much does it cost to put in this system and what's the payback period? Has that been estimated?
This is the big point. I mean, it's funny to know, for instance, that in Europe, the country that is a little bit more advanced in this kind of systems, either nature-based or technological, is Germany. And if you think about Germany, a country that is having problem of droughts, it seems quite strange. So the main driver to make it real essentially is a policy decision that is related to the cost of water. If the cost of water is starting to be around 3-4 euro per cubic meter, these solutions are starting to have a reasonable payback period. Otherwise, as it is happening, for instance, in some part of Italy, but even in other countries in Europe, you have policy-based water tariffs. I mean, water is a right, and so you need to keep low the price of the water to give access to the water to anyone. That is a fundamental right. But in this case, the water is starting to be so cheap, and I mean something around 1 euro per cubic. 1 euro per cubic meter. In this case, the payback period is starting to be higher and not reliable. And this is also a reason why this kind of solution is not getting so important in the market. They are starting to be considered, for instance, for big touristic facilities that is starting to have a different scale of payback period in comparison to a single house.
What's the approximate payback period, even with the subsidies on water?
When I mean reliable, I mean less, around 4 to 6 to 7. It means that with very cheap cost of the water, you are higher than 7 here. And
okay. But it's not a true calculation. Like, the city of whatever. I'm just making this up. The city of Florence in Italy. If they're subsidizing the water, to the outside observer, it looks like it's a long payback period, but to the city, it's a much shorter payback period because they're subsidizing it. So if the city requires it, why don't they use the math that actually affects the city to do it instead of what the customer pays? Because then it would make a lot more sense. And the city, planners would say, to the customer, it's a 9-year payback, but to us, it's a 3-year payback. So let's make everyone do it.
Yes. This is a point. Actually, we, in our talk now about greywater, we still didn't touch the main barrier, in my perspective, That is, on one side is the inertia, so it's new, and so no reason to do something different than the past. But actually, the real barrier is the fact that in comparison, greywater is one of the three pillars of sustainable water management that are water saving, reuse, collection, harvesting, and reuse of stormwater, of rainwater. And the third pillar is greywater. Of these three, greywater is the most difficult to be implemented because it's easy to imagine how difficult it could be to retrofit an existing building in which the greywater is not already separated. No? And this is also making difficult to plan for it, because how a city could plan to oblige any several building to separate greywater from an existing building. It's nice to have a project like NICE, because we are experiencing many different cases in which you have to try to separate from an existing building the greywater. And you could have different solutions, but not being so simple is also making more difficult to plan it.
In a typical building where it's not separated, where do the two sources of water, do they meet at one point or at multiple points in the system? And what makes it hard or easy to separate them?
Yeah, it depends on the building. For instance, in NICE, we were studying two cases for retrofitting. One is an hostel, and another one is a multicultural center. Old building in both cases. But in the hostel, we recovered the drawings of the building, and we have seen that the bathroom, so black water, has been connected to the wash basin, the shower of the room of the hostel, vertically on the outside the room. In this case, the retrofitting would be easier because it's enough to, let me say, break the wall.
Yeah, Anacleto, I'm sorry, I lost you for the last 10 seconds. Would you mind repeating that answer, please?
Yeah, sure. It's funny because we were trying to find a place to install a demo site of green wall in Turin, in the municipality of Turin, within the NICE project. And we had two different buildings, both public. One is an hostel and one is a multicultural center. And in the two cases, the separation of the greywater was completely different, because in the hostel, we have been able to, that were a recent restoration in the last 10 years. So we were able to find the drawings of how exactly the pipe have been connected inside the building. And we have seen that the bathroom, the black water, is connected to the greywater pipe vertically on the external wall of the building, not inside the bathroom. This means that to do minimal retrofitting, it would be enough to break the wall outside and to install a separated pipe. Can you imagine a pipe close to the one for the rainwater, for instance? You have two pipes outside, not so difficult. While instead, in the multicultural center, we didn't have this information. And so essentially, in this case, the retrofitting, at least for the wash basin, should be different. We really have to go down to the wash basin and with a separated pipe attached to the wall of the bathroom, go outside with the pipe. So, and essentially recreating externally, because otherwise you have to reconstruct from scratch, essentially, the bathroom. You are having this outside pipe that is taking the water from the wash basin and is going outside the building. So two different, essentially the same idea. I want to reuse greywater, but in two different conditions, two buildings, two different options to try to separate greywater in an existing building. I hope to have been clear enough.
Makes a lot more sense, yeah. Are there any cities that are mandating any new construction or any major renovations that the gray and the black water is separated?
Yes, because actually in this case, a good driver is starting to be, for instance, the environmental labels. For instance, I'm aware of the WEED, W-E-E-D, if I remember well, In this environmental label, you get point, you have to reach a minimum score to have the label. And you get point according to different environmental solution that you are using in your building. And you have a lot of stuff. You have energy, you have all the aspect of environment. But in terms of water, these labels are starting to ask to giving prices also for greywater separation. This means that if you are constructing from scratch a building, you are in a place that is not asking you to separate greywater from blackwater, you have also this driver. You have the driver of eco-label or WEED. This maybe we have to cancel. Is LEED, LEED. LEED certificate is asking for greywater separation.
Yeah, I've heard of the LEED standards. That makes sense. Okay.
Yeah.
Well, very interesting. I know you're working on a lot of other projects. And if it's all right, I'd like to have you back on the podcast at some point. But for now, I think this is a good, first foray into the work you do. So how can people follow up and find out more about you and your work? Where can they go?
Essentially, they can follow the social media pages of both of Iridra, mainly, and we have Facebook, LinkedIn, Twitter, and Instagram. And there is also my personal account on LinkedIn that I used to be quite active on, and I used to update what we are doing on it. So you can find me on LinkedIn.
And Iridra is spelled Iridra. Iridra.com,
Yes.
Is that right?
Yep, exactly.
Okay, and your name is Anacleto, Anacleto and Rizzo, Rizzo. Is that right?
Yep.
Okay, I just want to make sure people can find you, because you have a little bit of an accent, but it's okay. So thank you, Anacleto, for coming on the podcast.
Thank you, Richard, for hosting me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.